This is the October 28th, 2011 Math SAT question of the day. The stopping distance of a car is the number of feet that the car travels after the driver starts applying the brakes. The stopping distance of a car's driving along, apply brakes, car's driving along, no brakes, apply brakes here, this is the stopping distance. Car comes to a stop. Stop sign. The stopping distance of a certain car is directly proportional to the square of the speed of the car in miles per hour at the time the brakes are first applied. So you have a speed here. You have a speed. As soon as you apply the brakes, you have a speed. The stopping distance is some proportion, directly proportional to the square of the speed. Let's say speed, okay. Let's say the stopping distance d is proportional to the speed squared, where speed equals s when you start applying the distance. If the car's stopping distance for an initial speed of 20 miles per hour is 17 feet, so case 1 is 17 feet is the stopping distance for an initial speed of 20 miles per hour. What is its stopping distance for an initial speed of 40 miles per hour? So what is the distance in feet if it's proportional to 40 miles per hour squared? So what we can do is we can solve for k from the first equation, equation number 1, and then plug it into the second equation for to solve for feet. I think you can see that if you go 17 feet divided by 20 miles per hour squared, that's k, solving this one for k, is equal to x feet times or over 40 miles per hour squared. So that's k as well. It's the rate of stopping. That proportionality constant equals the same, is the same. Cross multiply and divide. Divide means I get 17 feet times 40 miles per hour squared all over 20 miles per hour squared equals what? Equals the stopping distance in feet. Because miles per hour, when they're squared, they're divided by, and it cancels out. So we should be good. So what's that in math? Let's do it here. So 17 times 40 squared all over 20 squared equals 68. 68 feet. The answer is D, 68 feet.